I'm going to work on the following problems here. We're going to go ahead and start with number 1. Let me give you the instructions. It says graph each function on the same axis as the parent functions. What is the effect of the transformation on the domain, range, x-intercept, y-intercept, and asymptote? What I do want you to do is I do want you to give me the domain, the range, and the asymptote of 1 and 2. I forgot to change the instructions. So what you're going to do is you're going to graph the new function, and you're going to graph the parent function. You're just going to find domain, range, and y-intercept and asymptote. So, and then you have to describe the effect. So that's 1 and 2. 3, 4, and 5, you have to describe it without graphing, but we're going to use the Desmos calculator, and you're going to see what the effect happens with the transformation that takes place. And then the last several problems is matching. So let's go ahead and graph the parent function. So we have y equals 3 to the power x. All you need is a couple of points to graph this. If you want to graph 0, 1, and there's a parent function. 0, 1, 1, 3. So the red one is the parent function. So now what I'm going to do is I'm going to graph, so let me write this again, y equals 3 to the power x. So now let's go ahead and write the new function, 1/2, and then we have 3 to the power x, and you notice there's a compression that takes place. So that's what you want to write down, and I'm going to come up with a table. So we notice I'm going to go ahead and use a different color. In this case, I'm going to use blue. And so we have 2 is 4.5. 1 is 1.5. So you notice it's going to be like this. You can just sketch it. And the transformation is a compression, vertical compression. And the only thing I want you to find is the domain for the new function. It's still negative infinity, positive infinity. The range, it's still y greater than 0. Now the y-intercept does change. The y-intercept, I have the point right here. It's 0, 0.5. Okay. So let me explain. All you're doing is you're sketching. Of course, I don't expect you to graph the very small y values. And what you're doing is you're sketching. Remember, I know it's asking for an asymptote. So this is your horizontal asymptote. Okay? That is your horizontal asymptote, which is y equals 0. For the next one, I'm going to graph the parent function, and I'd like for you to graph it also. 4 raised to the power x, that is a parent function. And all you have to do is graph certain points. So I'm going to say 0, 1. Oh, let's make a table. So remember, I want you to be practical, and I'm going to use red. You're not going to graph the smallest y values. All you're going to do is sketch. So I know it's 0, 1, 1, 4. And so I'm just sketching. This is the parent function. There's a parent function. So now what I'm going to do is I'm going to go ahead and graph the other function. Okay, so I'm going to graph the other function. So we have y equals 4 to the power shift 6 x minus 1. And you notice, oh, that's the wrong one. It has to be up there, so it's minus. So you're going to have to use parentheses and decimals, x minus 1. And you notice it's going to shift to the right. So the transformation that takes place is shifting to the right. So let me go ahead and write that down. The transformation shifts to the, in this case it's right. So I'm going to use blue to describe the new function, and I'm going to go ahead and use a table. And of course, I'm going to use 0 1/4 here. 0 1/4, 1, 1, and then 2, 4. And you notice that it does shift to the right. Once again, the domain of the transformation or the new function, or the function 4 to the power x minus 1, is all real numbers. We have a range in which y is greater than 0 because there is a horizontal asymptote, and it's at y equals 0. So domain, and then intercept, and we're going to look for the y-intercept. And the y-intercept is right here. The y-intercept, it's when it crosses the y-axis. So it's 0, 0.25. So once again, I use decimals to describe the transformation. I graphed the parent function y equals 4 to the power x, and then I graphed 4 to the power x minus 1 is shifted to the right. So we know that the black one, in this case, I did have blue. Of course, I don't know how to change the color here. I don't know how to change it, but it's black here, but it's actually blue one here. And this one is the red one, so that's parent function. So that's how you do question number 2. Okay, it says, without actually graphing, describe how the graphs of the following functions are related to 5 to the power x. Now, y equals negative 5 to the power x. That negative is going to reflect the parent function over the x-axis, and you're going to see that here. So we have y equals negative 5 raised to the power x, and you notice that the function is reflected over the x-axis, so go ahead and write that down. So graph reflected over x-axis. Okay. Number 4, that 2, it's going to affect the vertical, and what it's going to do, it's going to stretch it just like a rubber band. So you're going to see that here. I'm going to replace the negative with a 2, and you're going to notice what's going to happen. Just like a rubber band, and I'm going to put times here so you can see it's multiplied. It's stretched. So I'm going to put here stretched, vertically stretched. Number 5, you have y equals 5 to the power x plus 2. Remember, this is very similar to number 2, so it's plus 2. Remember, it's going to shift to the left, so you're going to see that here. And remember that you will have to have parentheses x plus 2, and there you go, it's shifted to the left. Number 6 has multiple transformations. So you have x minus 3, which you know, if x plus 2 shifted to the left, then x minus 3 is going to shift it to the Right, and you saw that. And the plus 2, which is outside the parentheses, is going to move it up. So now your horizontal asymptote is y equal 2. So let me write that as multiple transformation shifts to the right and moves up vertically, right? Okay, so if you have any questions, please see me during student support. The next ones are basically matching. And so I'm going to go ahead and do 7, 8, and 9, but I'm going to use the transformations so you can understand. The parent function, remember the parent function is 3 to the power x. So we have 3 to the power x plus 1. So that's going to move the parent function up 1. Okay, so it's either B or C. So in this case, if you want to make a table, you can. 0, 1. Oh, well, I'm going to have to fix this here. So it's plus 1. So now the y-intercept is 0, 2. So the only one has a y-intercept between B and C. So number 7 is going to be answer B. So this is B. So that one's out. So now we have 3 to the power x minus 1. So minus 1 is going to bring the graph down 1. So you're going to see that here. It brings it, and it actually goes through 0 because that's the y-intercept. You see that there. So your answer for number 8 is A. So just by elimination, we know that 9 has to be C. It has multiple transformations. X minus 1 means it's going to shift to the right 1 unit, and that plus 1 is going to move it up. So the answer for number 9 is C. All you had to do for 7, 8, and 9 was matching. It was just matching. I went ahead and added the power e, which is an irrational number. We have e raised to the power x. And we know that e to the power x minus 1 is going to shift to not the left, but it's going to shift to the right. So what I'm going to do is I'm going to show you here using Desmos, x minus 1. And you notice when x is 0, it's 0.3, and then we have 1, 1. So we know that the answer is 11 is C. We know that the answer for number 11 is C. We know for 12, it's e to the x, and you're going to subtract 1. So that means the asymptote is going to go down 1 unit. So it's going to look like B. 12 is B. And of course, by default, 13 is 2 times e to the x. That's going to affect the vertical stretch, or it's going to be vertically stretched by a factor of 2. Okay, and your answer is A. If you have any questions, please see me during student support. Thank you, guys.